In this video lecture, we will learn how to solve economic dispatch problem, including losses. In this, we are using gradient search method algorithm. So this is, we'll be discussing the algorithm or steps to solve this problem. While discussing this algorithm, we'll come across many equations, such as in step number 5, to calculate the power output, we are using this expression here. Similarly, in step number 7, we are using this expression. So now this expression, the derivation of this expression is out of syllabus, so that is the reason why I'll not be dealing with those derivation part, that is out of syllabus for you all. Only the algorithm is needed, and the problems on this algorithm is there. So you need to focus only on these two parts. You don't have to learn this expression for the exam, but I will provide you all with the notes on these derivation, and it is already available in the textbook. You can go through the derivation for this part. Okay, so but it will not be covered in your syllabus. So from exam point of view, these derivations are not there. You need to only understand this derivation and also memorize this expression for solving the problem. So starting with the steps, first one, we need to read the following data: number of generators, cost coefficients. This is obtained in the incremental fuel cost expression. Next, B coefficients, which we can retrieve from the power loss expression, power demand, and convergence tolerance. The convergence tolerance actually decides the number of iteration. Next two steps are based on initializing. So first one, we need to initialize the value of lambda. Now this initializing the value of lambda is based on two approach. One is simple assumption. Second one is determining it using this expression. Now coming to assumption part, you can assume the value of lambda. Now what range of values should you take to as an assumption or as a assumed data is that it should be nearer to BI value. But whenever you are assuming any value of lambda or initial value of the lambda, make a note that or specify that what value of lambda you have assumed. So make sure that your assumed value of lambda should be somewhat nearer to BI value. Okay, so next, the other approach of determining the initial value of lambda or estimating the initial value of lambda is using this expression. This expression we have used while solving economic dispatch problem without loss. So there we had used this expression. The similar expression or the same expression is used here to calculate the initial value of the lambda. See, this expression is used only to calculate the initial value of the lambda. Next, we have the initial value of power output. For step number 5, we require the initial or the previous iteration value. Now, since for the first iteration, the previous iteration value is calculated using the 0th iteration. Now, this is nothing but we are using again the without loss power output expression that we had used in the previous derivations. So that expression is used for the 0th iteration, so that in this step number 5 we can use the previous values, previous iteration value. Okay, so now we set r equal to 1. This actually specifies the number of iteration. We will start with the first iteration. So coming to the first iteration, our first step is to calculate the power output of all the n generating units. So this is the expression we get. Here, as I've told you, we require the previous iteration value. Now, why do we require previous iteration value? And also there is a statement called as use the latest value of power output. What does that mean? So to better understand that, we have these expression. This is nothing but whatever expression you have we have used here for 3-bus system. So these are the resulting expressions you will be getting for power for plant 1, plant 2 and plant 3. So these are the expressions you will get. So while calculating power output in the first iteration, we require the power output in the second and third plant. Now that is calculated using the previous iteration values. Now for the first iteration, this will be your 0th iteration values. So that is the reason why we had calculated PGI of 0. Okay, similarly, while calculating the power output of second iteration, we require again the power output of the first plant and the power output of the third plant. The power output of the first plant, we will be using the latest value. It means whatever value we have calculated in the present iteration, that value we can use. Whereas coming to third plant, we have not yet calculated the first iteration value. So there we will be using the previous iteration value. To be simple, while calculating the power output of any plant, if you require the power output of a kth plant, and if that kth plant power output is already estimated in that iteration, you can use the rth iteration value. If that kth power output is not yet estimated, then we have to use the r-1 iteration value, that is the previous iteration value. So here in the second plant, the first unit power output is required. Since we have already estimated it, we can use it. But here the third plant power output is also required. Since we have not estimated it, we will be using the previous iteration, that is in the first iteration we will be using the 0th iteration value. Similarly for third plant, both first and second unit or second plant power output is required. Since we have already estimated it, we will use that, which means that always use the latest value. If the latest value is available, we will use those value. If it is not available, we will use the previous iteration value. So this is how the power output will be calculated. So next we will calculate the P loss. The expression for P loss is somewhat like this. Okay, this is how the P loss for 3 generator system will be. Okay, so using this expression we will calculate the P loss value. Next we will calculate dPgi by d lambda. Now here again these are the expression for 3 generator bus system. Okay, this is the same equation when we make it for 3 bus system. This is a general expression for 3 bus system. These are the equations you get for all the 3 generating buses. So here again we will be using the first iteration value only. Okay, because these are already estimated. Clear? So using these expressions we will be calculating dPg1 by d lambda, dPg2 by d lambda and dPg3 by d lambda in the first iteration. So once we have calculated that, next we will be calculating delta P of R. Delta P of R is nothing but the error between the actual demand and the estimated one. So these two, what you can see, this is the estimated one, okay, and this is the actual demand. So the difference between this is nothing but delta P of R. Later we'll calculate delta lambda of R using this expression. Once we have calculated delta lambda of R, next we need to check if delta P of R is greater than or equal to epsilon value. This is epsilon value, which is nothing but your convergence tolerance. If it is greater than it, it means that we have not reached the desired accuracy level. If delta P of R is less than epsilon value, it means that we have reached the desired accuracy level. So we don't have to go for next iteration and we can stop there. But if it is greater than epsilon value, then we need to update the lambda value using this expression, and we will go for the next iteration and we'll start again from step number 5. Clear? If we have reached the desired accuracy level, then we will stop and print the values, or we will get these values as the final values. So this is the step for solving economic dispatch problem including the loss. Now here in these expressions, we have written the equation for 3-bus system. Now for 2-bus system, you will have expression somewhat like this. So for 2-bus system, Pg1 of R will be equal to lambda R minus lambda R into 2B12 Pg2 of R. Since there are only 2 plants here or 2 generating system here, we will be having only one term here. Okay, so there will be only one term here. In case if you have 3, then that you will have 2 terms within this square bracket. Okay, if there are 4 generating plant, you will have 3 terms within this square bracket. Similarly, Pg2 of R we will calculate using this expression. P loss expression will look somewhat like this. So always remember that your B12 will be equal to B21, or I can say Bij is equal to Bji in power loss, and the dPgi by d lambda is calculated using this expression. This is C1. So using this expression, we will calculate dPgi by d lambda. So these are the equations you use for 2 generator system, and these are the expressions you use for 3 generator system. Okay, so these can be used to solve the problem. So in the next video, we will solve the problem and understand this algorithm in much better way. Thank you.